All right, students. For last week, we already learned some very basic probability about Poisson distribution and also the mean and variance for Poisson distribution. So for today, we are going to continue with application questions. Okay, how Poisson distribution can be a model for the application question. All right. Okay, so let's have a look for the learning outcome today. So for the learning outcome today, what you need to do is now you need to know how to identify the Poisson question, okay, and how to use it as a model, okay, in the application type of question. Right. Okay, so first of all, you need to know for Poisson distribution, we know that the lambda is the mean, right? Okay, so usually the lambda will be given in the question. Okay, so for this lambda, when they give in the question, that they will give you in a given time interval. Not necessarily time interval, but usually it's a given interval. And you need to know that this lambda is actually proportional to the size of the interval. That means if let's say the interval change, then the lambda will be changed also. Alright, so as an example, if let's say in the particular question, they tell you that, okay, I'm having 5 cars pass under the bridge for 1 minute. So the 1 minute here will be the time interval, and the mean lambda is 5. Okay, so if let's say the question asks you for 3 minutes, what is the mean now for 3 minutes? So it will be 3 times 5 equals to 15. Because 1 minute is 5 cars, right? So for 3 minutes, you need to have 5 times 3, which is equals to 15. So for 5 minutes, you need to take mean times 5 equals to 25. So if you are having 3 minutes, then that means you are having mean as 5t. Alright, so please remember that the lambda, you need to change it up if let's say the interval given is different from what they want you to calculate in the question. Okay, so let's have a look for the example here to see how we apply all these concepts. Okay, so now, first of all, I will tell you how to look at the question and know that it belongs to Poisson distribution. Okay, so for example 6, if you look at it now, of course they already give you a keyword here, Poisson distributed. How about if let's say they didn't give you this word? They only tell you that the number of demand for 6 taxis to a tax firm is denoted with X, and then on average 4 demands every 30 minutes. If let's say they didn't give you this keyword Poisson, then when you want to look for the Poisson distribution, you are looking for the interval. So you highlight this one, every 30 minutes. So the every 30 minutes is the interval given in this question. Alright, so from here you should roughly know that it belongs to Poisson distribution. Okay, so let us answer the question now. So, okay, wait, I need to scroll down again. Okay, so as an example, when you look at example 6, right, they are talking about the number of demand. So if you want, you can write out X is equals to the number of demands. Right, and then for part A, what they want you to answer. So they want you to find the probability of no demand in 30 minutes. So you compare this interval in the question, compare it with the one that we give in the question, part A, and also the original question here. So both are also 30 minutes. So the interval, therefore, you no need to change the mean. So the mean is still a 4. Number of demand equals to 4, okay, for every 30 minutes. So they want you to get the probability of no demand, so X equals to 0 when the mean is 4. Alright, so you're having E negative lambda power X divided by X factorial. Okay, so this is what you have, and just by pressing calculator, you'll get 0.0183. So I think this is very simple, right? Okay, so I hope that you can do it and you understand that. Okay, so now we continue to part number B. So part number B, they are talking about one demand in 1 hour. So from here, you can see that, okay, now the interval given is different already. Just they give you 30 minutes, 4 demand in 30 minutes, and now they are asking for 1 hour. So before you calculate the probability, you need to change, right, the mean. Okay, so it is 4 for 30 minutes. So 30 minutes and 1 hour is, what's the difference? So 1 hour is actually 2 times of 30 minutes, right? So the mean is 4 for 30 minutes. You need to multiply it with 2 so that you get a mean for 1 hour. All right, so 4 times 2 equals 8. And then from here, you try to calculate the probability. So you let x equals to 1, x equals to 1. One demand, right? So the number of demand equals to 1. So to calculate the probability, you'll get E negative lambda, lambda power 1 divided by 1 factorial. And from here, you will be able to get an answer also 0.00268. Can see another idea that we change the mean according to the table given. Right, so this is how we do it. When you are solving the Poisson type of question, this is something that you need to take note of because you need to refer to the interval given and then you change the mean accordingly. Alright, then let's have a look for part number C. So fewer than 2 demands in 15 minutes. Okay, so again, 15 minutes is different from the interval given in the question. So in the question, they give you 30 minutes. So 15 minutes is half of it. Therefore, the mean, you also need to divide it by 2. So divided by 2, you get a 2. Okay, so this is the mean for 15 minutes. And they want you to calculate the probability for x smaller than 2, fewer than 2 demands. Therefore, you have negative e power negative lambda. The first term, x equals to 0, is always a 1. The second term, x equals to 1, is always the lambda. So this is the lambda. And if you press calculator correctly, you should get the answer 0.406. Okay, so these are the answer that you get. So it's quite simple actually. If you look at the idea here, generally when the interval is different, then you need to change the mean before you can calculate the probability. Okay, so this is what we have for example 6. So should be no problem, right? It is quite straightforward and easy to understand. All right, so let's have a look for example 7. Okay, so for example 7, if you look at it again, they already give you the keyword Poisson distribution. If they didn't give you this keyword Poisson, then when you look at it, you should look for this one during the school week, Monday to Friday. So the school week per week means 5 days only because they are talking about school week. All right. So during the school week is an interval given in the question. Something happened. Okay. The number of breakdown is 8 times during this interval. So from this phrase or question or sentence, you know that it is actually a Poisson distribution question. Okay, right. So this is how we detect it. So for binomial also the same. Like last semester, maybe I teach you already how to detect the binomial style question, but the structure is not so obvious. For Poisson, to me, it is more obvious. All right, so you have to make sure that you know how to differentiate the Poisson type and also the binomial type question. Yeah. Okay. All right. So for this example, I will just leave it for you to solve it. Okay. So the answer given. I'll give you only the final answer, and if you cannot get the answer, please ask me in the Facebook Messenger, or you can ask your friend first if your friend know how to do it. Okay, so this is what we have. Okay, so I'm not going to show you the detail of the steps, so you try on your own. This question actually is very, very easy also. All right, so please complete this example 7 by yourself. Right. Okay, so let's continue to example 8. Okay, so for this question, example 8, if you read through the question again, so for this one, they didn't tell you any keyword for Poisson, right? You didn't see the word Poisson in the question. All right, but if you look at the question itself, you will see the hint again. The number of call is 2 per hour. So the per hour here is the interval. And see that it is the interval per hour. Therefore, you can actually you can actually conclude that this is a Poisson distribution question. Okay, because the interval is given here, and they give the number of calls for this interval. All right, so now let's start with the question. So first, calculate the probability that in a randomly chosen 1 hour period. So they give you the mean for 1 hour, and they want you to calculate the probability for 1 hour. Therefore, the mean here should be the same. All right, so for part A, no emergency calls are received. Okay, so you can write X is the number of emergency calls. All right, so X is Poisson distributed with the mean 2. Okay, so they say no emergency call are received in 1 hour, so X equals to 0. So E negative lambda, lambda power 0 divided by 0 factorial, and you get 0.135. Okay, so this is what we have. Right, then now we go to part number B. Please read the question carefully for part number B. Okay, so exactly one call is received in the first half hour and exactly one call is received in the second half hour. So for this particular question, they actually split the interval become 2. Okay, so that means you have half an hour, first half an hour, and also the second half an hour. So the interval actually is different already because in the question it gives you 1 hour, but now they split it become 2, half an hour. Okay, so for this kind of question, again, you need to change the mean. Okay, so the number of call is 2 per hour. Therefore, it will become 2 divided by 2 equals to 1 for half an hour, right? If you want to write out like this also can, just to remind yourself that the 1 is for half an hour. Okay, so the setting of the question now is first half an hour, you are having 1 call. So that means when you want to find the probability, it should be x equals to 1. So this one is for first half an hour, and then another call received in the second half an hour. So when you write out, it should be x equals to 1 also. Alright, and then to complete the total 1 hour, you need to multiply them. It is not a plus, it should be a multiply. Okay, so what is it multiply is because of in total, they still want to calculate the 1 hour probability. Just that for the second part, they split become half an hour and half an hour. So if let's say for this half an hour, it is not completed, it is not complete as 1 hour, right? So you have to multiply both half an hour to get the hour period. Therefore, you multiply it. Okay, so what is the probability for this one? Now you're having E negative lambda, lambda power 1 divided by 1 factorial. Multiply with another one, E negative lambda, lambda power 1 divided by 1 factorial. And end up you'll get also 0.135. Okay, although these two answers are the same for part 1, part A and B, but generally the step is different. Okay, so for part number A, when they say no emergency call are received, means that in this 1 hour there's no call. Okay, but for part B, you cannot write in something like this. Some students they will tell me, so in total they receive 2 calls, right? So can I find out the probability for x equals to 2 or not? And then I have E negative lambda, lambda power 2 divided by 2 factorial. Is this step correct? It is wrong. Because according to this question, you need to follow the meaning in the question. Because for this question, generally what they have is, you are having 1 call in first half an hour, another call in the second half an hour. So you calculate the probability, it should be separated into 2 half an hour, and you calculate, then only you combine them. Okay? So if let's say you do it like this in the green color one, then the question will be something like exactly 2 calls in an hour period. So when they say exactly 2 calls in an hour period, that means maybe the 2 calls can appear the first 15 minutes, and then the rest of the time there's no call. Understand what I say or not? So it's very particular. So make sure when you calculate the probability, please make sure that you follow the meaning itself in the question or in the sentence. Right? So this is what we have for example A, part A and part B. This is the difference. And then please have a look for the green color part. If you are doing it in green color part, that is wrong. Because if you want to do it in green ink color like this, then the sentence, it should look something like exactly 2 calls in an hour period. Alright, okay. So if no problem, then we will proceed further. So I hope that all these small details, you need to be very careful, because a lot of students, they will always do it wrongly without following the meaning of the questions that they want. Alright, so please make sure that you really understand the question and also the sentence very detailed when you want to solve this kind of question. Alright, so this is what I have for example 8. Okay, then continue. Example 9. Okay, so if you have a look for example 9, what do we have here? They are talking about the number of emergency telephone call again to the electricity board office in a certain area in T minutes is known to follow a Poisson distribution. So Poisson is a keyword. If let's say they didn't give you the word Poisson distribution, then you can see that in T minutes. So in T minutes means it is still the interval given. Okay, and the mean given is 1 over 80 T. Alright, so T is actually the time, and T is measured in minutes. It is written here. So first, they want you to find the probability that there will be at least 3 emergency telephone calls to the office in any 20 minutes period. So this one means that T equals to 20. Alright, so you substitute T equals to 20 into the mean here, and then you calculate the probability. So this is a very easy question. I want you to try on your own. You will get 0.00216. Okay? Then the next one, the probability that no emergency telephone call to make to office in a period of K minute is 0.9, and they want you to find the K. Okay, so for this example, we will discuss it together. Okay, so now, they are talking about K minutes. So for the mean itself, it will be 1 over 80K. Alright, so maybe I will write it like this, is easier. K over 80. The mean is K over 80. And from the meaning of the sentence, they say the probability, so the number of emergency telephone call is X. No means equals to 0. Okay, is 0.9. So that means this probability itself is 0 equals to 0.9. Okay, so this is how we translate a sentence into a correct symbol, and after that you continue from here to get the answer that you want. Alright, so this is the information given. X equals to 0, the probability is equals to 0.9. Okay, so what is the formula for X equals to 0 for Poisson distribution? So E negative lambda. So you're having lambda power 0 divided by 0 factorial, and it is equals to 0.9. Okay, so again, the same concept that you learned before. No matter what is the number that you have here, it is always equals to 1. And then this number itself also always equals to 1. Alright, therefore, you have E negative K over 80 equals to 0.9. Alright, okay, then next. What is the next step that you can do so that you can get the value for K? Alright, so I think I told you before, if let's say you're having anything like K or X as a power, right, you have to take ln or log both sides to get the answer. So because I'm having the base E here, therefore I would prefer to take the ln both sides. So I'm having ln E equals to ln 0.9. So what's the value for negative K over 80? You'll get ln 0.9. And then when you move everything over, you will get 8.43. Okay, so this question is slightly special, but I think you can do it also. Yeah, alright, so that you have the idea. They can ask you the question like this also without not always asking probability, but they give you the probability value and they ask you to find the mean. Okay, so for this case, you need to apply a little bit of your maths knowledge that you learned before. Okay, so either you take log both sides or ln both sides. Alright, okay, so no problem. Then again, we proceed further. Let's have a look for example 10. Okay, so when you look at it, they are talking about weak spots, okay, occur in the manufacturer of certain cable, and then a rate of 2.5 weak spots per 100 meters. So the per 100 meter length is the interval given. So from this phrase, you know that it belongs to Poisson distribution. Okay, so we are talking about X equals to the number of weak spots. The number of weak spots. Okay, so according to the question they did ask, then you find out the probability lah. So these two parts, the answer I will give you straight away because the question is very straightforward. This first part answer is 0.0821, and for part B, the answer is 0.456. Okay, then now we continue to this one, number 2. Okay, Paul cut 8 lengths of cable, each 100 meter long. So that means Paul, he has he had 8 cables. Every cable is 100 meter long. Okay, and then they say find the probability that exactly 2 of them. What is the meaning of them? That means that they are talking about a cable, right? Okay, no weak spots. Okay, so for this question, they are focusing on them. 2 of them, something happened. So can you guess what is the distribution for this question? So this is actually binomial distribution. Can you see or not? Although the first part on top, they are Poisson, but if you look at this question, they tell you that I'm having 8 cables in total, and then in the question itself, they said exactly 2 of them, something happened. So the something happened means have no weak spots. So this kind of structure is actually binomial distribution. And another hint for you is, if you look at the on the first part, they are talking about the number of weak spots. But for the second part, they are talking about the number of cables. So they are talking about 2 different things. So you should suspect that actually the distribution already changed, or maybe the variable that we have already changed. Okay. So for me, I will write it out like this. Y is maybe I write out the number of cable first. So define Y as the number of cable. If you want it to be more completed, then you should write have no weak spots. Okay, so from here, Y is binomial distributed 8. And what's the probability that you should put here? So you should put the probability of the cable not having weak spot. What is the probability for cable not having weak spot? The answer is in part A already. So you should put 0.0821 in this question. Alright, yeah. So this is the question that we always like to ask students because a number of students actually they cannot answer part number 2. They didn't realize that it has been changed to binomial distribution. Understand what I say or not? Okay, so actually Y is binomial distributed, and they say find the probability that exactly 2 of the cable have no weak spot. So you have to find the probability Y equals to 2. Okay, so again, I'm not going to show you the detail for the steps here. You attempt it on your own. The answer that you get for this question it should be 0.112. Alright? Can Okay, so this is one example that they combine Poisson and binomial together. So don't tell me that, hey, I thought binomial is in semester 1, right? It shouldn't be included here. But for your information, for math knowledge, right, all the basic knowledge that you learn, they can appear anywhere. Alright, but maybe for stats 2, one good thing is permutation and combination is not here. You won't see permutation and combination at all for this part, for stats 2. Alright, and also all the probability methods that you learned before, but on up we are still using the conditional probability formula, right? Okay, done with example 10. Okay, so make sure you completed your solution here. You don't just put dot like me. Okay, so please make sure you complete your steps here. Once you have chance to go back to college, I'm going to check your solution one by one. Okay, all right, so make sure you complete it. Okay, then now let's continue to example 11. Okay, so for example 11, again, you see the keyword Poisson distribution. And then if let's say they didn't give you this word, then the per week will give you a hint that this is a Poisson distribution. Okay, so now what is the Poisson distribution? What is the X? So if you read this question, they are talking about the demand for fans. All right. Okay, so they are talking about the demand for fans. So X is equals to the number of demand for the fans. Okay, so we are talking about the number of demand because from this question, they will tell you that it is the number of demand. Okay, so here, first question, find the probability that the demand is exactly 2 fans in any 1 week. So again, they are still asking for 1 week in the question itself, so you no need to change the mean. So the X is still Poisson distributed and the mean is 3.2. And they want you to calculate the probability X equals to 2. Okay, so again, I later to write out the steps for you and please try it on your own. Answer is 0.209. Okay, so this one very straightforward. I will just leave it for you, okay, to save time. Right, to save my time. Okay, then you do it on your own. Okay, then let's have a look for part number 2. Okay, so now they say part number 2 is the shopkeeper 4 fans in his shop at the beginning of a week. Find the probability that this week will not be enough to satisfy the demand for fans in that week. Again, they are still talking about a week, right? So the mean is still the same, which is 3.2. Okay, so now my question is, how can you write out the correct symbol? What do they want for this one? How can you write it out? Okay, I give you maybe 30 seconds to think about it, or maybe 1 minute to think about it. How can you write out the symbol correctly? Okay, so how should you do that? Any idea? Okay, so you're having 4 fans, right, in the shop. So they say this 4 fan will not be enough to satisfy the demand. What does it mean? That means that the demand should be more than 4, right? Because not enough also. If let's say the demand is equals to 4, then just nicely fitted, okay? It is just nicely satisfied the demand. But if let's say the demand is more than 4, that means 4 fans is not enough to satisfy the demand already. So you need to calculate the probability for X greater than 4. So again, the steps here, I will not show you how to do it. You do it on your own and you should get 0.219. All these are very easy, so I'll just leave it for you. Okay, just for this one, X greater than 4, you need to think a little bit more because X, we are talking about the number of demand. So if let's say the demand is more than the supply, so it should be X more than 4. Okay, all right, then continue further. Okay, so given instead that he has N fans in his shop at the beginning of a week, find by trial and error. So here they tell you that, okay, the method that we use is trial and error method. Okay, the least value of N for which the probability of his not being able to satisfy the demand for the fan in that week is less than 0.05. Okay, so this question very similar to part number 2, right? Just part number 2, you are having N fans. And then they are still talking about not able to satisfy the demand one. So this question is very similar to part number 2. All right. Okay. So now, what they say is, they want to find the value of N for which the probability, so Peter, he's not able to satisfy the demand. So for this case, not satisfy the demand will be X should be greater than N already because you're having N fans, but it is not enough. So it should be X greater than N. In that way is less than 0.05. The probability is less than 0.05, so smaller than 0.05. Okay, so now from here, how can you continue to get the value for N? Right, so for Poisson distribution, I think I told you already, this one cannot be solved one, right? You have to take 1 minus. So it will be 1 minus X smaller equals to n, which is smaller than 0.05. And then if you move all the things to the other side and whatsoever, right? Okay, wait. I think you'll get something like this. X smaller equals to n, it will become greater than 0.95. Okay, so if you try to expand the value, the formula for x smaller equals to, you realize that you cannot solve it one. Okay, therefore, in this question, they already mentioned clearly that by using trial and error method. So by using the trial and error method means what? Means that you have to start from the value that you think should be the answer. Okay, by trial and error. Okay, so actually you should start from x smaller equals to 0 and then x equals to 1 and so on to check and see whether what is the value of n. But because I think it is very impossible to be 0 and 1, to save time, I will already start with x smaller equals to 2. Why I decide it as 2? Suppose you should start from 0 and 1. 0, 1, then 2, then 3, then 4. Okay? But I'm quite confident that the answer might not be 0 and 1, therefore I start from the 2 first. So what is the probability for x smaller equals to 2? So you have e negative lambda. So what is the lambda that we have? Okay, so the lambda is still the same. For 1 week is 3 point, right? Then lambda, smaller equals to 2, right? So that means e negative lambda, then the first term is 1, x equals to 0. X equals to 1 is lambda 3.2. And after that, 3.2 square divided by 2 factorial. Okay, so for x smaller equals to 2, you'll get 0.380. Okay, so please double check and compare it. Is your value, is the value that you get more than 0.95 or not? It is less than 0.95. Alright. Then therefore, what you need to do is that the 2 is not your answer. You have to continue and try. Okay, so maybe you try x smaller equals to 3 lah. So in your step here, once you show the formula for one time, you need to show it again. Okay, so for this one, you can actually calculate out without writing out the formula. So you get 0.603 for this one. It is still smaller than 0.95. So that means 3 is not the end. Okay, then again, you have to continue for x smaller equals to 4. Okay, then you get the value and then you compare it, whether is it more than 0.95. Okay, so please continue until you get the probability which is more than 0.95. Then you stop. So this is the value of n. Okay, so again, all the details I will not show you. I will only tell you the final answer. You can straight away write after you show all the steps here. Then you can write n equals to 6. All right. Okay, so this is what I want to discuss with you for this video. And then we are still having another video for example 12. But now I need to go to a meeting, online meeting now. So I will continue in another video, in the next video for example 12. All right, so please complete all this first. Okay, so I will discuss with you again for the next video, for the next example.